Hello, everybody. We're still talking about the basics and the main concepts that we need to know about mass transfer, and this is going to be the last part, like the last video in this part. And in this video, it's pretty important because it discusses an important point, which is the modes of mass transfer. And by the modes of mass transfer, I mean how the mass is transferred from a point to another. And there are two main methods of or modes of mass transfer, and this is going to be a part where we will see some similarities between mass transfer and heat transfer, and this is going to be a point that we're going to be emphasized a lot in this course, where we will be comparing what we know about heat transfer with what we see here in mass transfer, and we will see a lot of similarities and a lot of things that are common between the two modes of transfer or transport phenomena in general. The mass transfer can take place by first molecular diffusion, and by molecular diffusion we mean that the diffusion that is affected or it's driven mainly by the difference in concentration. So as we see in this photo here, we have three components in the same medium: the blue, green, and red components. And the blue and green are almost distributed in the whole area in a homogeneous way. So there is no driving force that we can consider for the two components. But for the red component, we would see there are many molecules here. There is a high concentration in this part, and there is no molecules of the same or this component here. So what will happen is the diffusion of these components from a point to another, and this is what we mentioned about the driving force. But what makes or what differentiates the molecular diffusion from the other mode of diffusion is that the diffusion or the diffusing molecules are diffusing within stagnant medium. So the two other components are not diffusing or are not moving from a point to another. They are almost, we can consider, of course, they're not stagnant, but they are considered stagnant compared to the other mode that we will discuss later. But this is what we mean. So the only driving force here is the difference in concentration. However, for the other mode is called convection, and the name tells a lot about what takes place here. So in this mode, we will have also a difference in concentrations. There is high concentration here, there is low concentration here, but there is a bulk flow, maybe due to a pump, maybe due to a fan or whatever. Like if you have a fan in a room and this fan is pushing air, and there is like a perfume or something, so this perfume will be driven with the bulk flow with the air molecules from a point to another. So this is what we mean by convection. The mass transfer is not driven by the difference in concentration in the first it's not the first reason or the first cause of mass transfer, but it is driven mainly by the bulk flow, which is moving all the components, including the component that has this concentration gradient. So this is the main difference between the two modes of mass transfer. If we compare these two methods with what we know about heat transfer, we will see like very, very similar similar methods in heat transfer. So in heat transfer, we know there are three modes, which are conduction, convection, and radiation. And for conduction, it's gonna be almost the corresponding method to the molecular diffusion. We have in the conduction, we have stagnant medium like any solid material or any stagnant fluid, air or liquid, and the heat is transferred due to the difference in temperatures, and it's affected by the thermal conductivity. So higher thermal conductivity means there is higher rate of heat transfer. And the same is here, which in this case in mass transfer we have diffusivity, which corresponds to the thermal conductivity. And this diffusivity is, if it increases, then, or if its value is high, then the rate of mass transfer is high, and vice versa. The convection is exactly the same. Here the heat is transferred because the hot molecules that have the heat are transferred from a point to another due to the difference in or due to the bulk flow. And the same here in convection, the high concentration is going to low concentration due to the bulk flow. The only difference here is that we don't have radiation in case of mass transfer, because in heat transfer it's a transfer of energy, and energy can take the form of radiation, while this is not possible in case of mass. So in this case we cannot have something that corresponds to radiation. So the two modes of transfer here are of mass transfer are molecular diffusion and in convection. We will go into more details about the molecular diffusion in the coming or in this chapter and the coming 3 chapters, and then the following chapters would be focusing on convection. And again, the similarities and the analogy between the different transport phenomena are going to be emphasized a lot in this course. And this I believe this is important so that you can link things together and see how the transport phenomena have common things and have similarities. So the next video we will start talking about Fick's law, which is the first law that was made to describe the molecular diffusion. So I'll see you then, inshallah. Goodbye.